Alright, so starting here with these systems of inequalities. So the first thing I'm going to do here is I'm going to graph these two inequalities. So I'm going to start with y is greater than or equal to negative x minus 1. My slope here is a negative 1 and my y-intercept is negative 1. So I'm going to put a point here, and then I'm going to be going in a negative 1 direction. Now what you'll notice on this problem is that there is no equal to in our inequality symbol. So I'm going to be using dotted lines or dashed lines to connect these points. Okay. You also notice that it is greater than, so I'm going to shade above this line, and I'm just going to pick a colored pencil to be able to do that. And I'm going to shade in yellow above that line. Okay. Alright, on the next section here, I am going to go ahead and plot these points as well. So I have 0, negative 5. But on this one I have a positive 1 slope, so I'm going to go ahead and plot those points as well. And I notice that it is not an equal to, so I'm going to use dashed line. And it is a less than symbol, so I'm going to be shading below that line. And so that's going to be this area right here. So this place where they are doubly shaded, I'm just going to grab a regular pencil and kind of shade that in a little bit darker so that I can see that these are all part of the solutions. Now, what we do need to remember here is that anything that falls on the line, because they're dashed lines, are not part of the solution, but anything out here, and that includes anything way out here as well. Okay, this is all still part of the solution way out here, even though it's not on the grid. The grid does keep going forever, so keep that in mind. That's also a part of the solution. Alright, so looking at number 2, you'll notice here that I went ahead and converted these over into slope-intercept form. I subtracted the x, I divided by the negative 4, I ended up with y is greater than or equal to 1/4 x minus 6. Keep in mind that I do have to flip the sign because I divided by negative 4 here. So I'm going to put a point at 0, negative 6. And I'm going to use a 1/4 slope. Now, because this isn't equal to, I can go ahead and use a solid line. Okay, and because it is greater than, I'm going to shade above that line. Okay, alright, then from here I already have one in slope-intercept form, so I'm going to have 0, 1, and a positive 2 over 1, down 2 over 1, okay. It's also an equal to symbol, so I can also use a straight line on this one. And it is things less than this number, so I'm going to be shading below it. So just to kind of darken this in to make it visible, you'll see that my solution set is going to lie right in here. Remember, it does continue on forever because that is a grid. It'll continue in between those two lines. And anything that's on this line will be included in the solution because it's a solid line, not a dotted line. Okay, alright, let's look at question number 3. So here we have an x is less than negative 4. So that means we put a point at x is less than negative 4, and we make this into a vertical line. But it is a dashed line, not a solid line, because there's no equal to symbol. And when we say less than negative 4, just think about which numbers on the number line are less than negative 4. In that case, they are to the left of negative 4. Okay, the next one, I've gone ahead and converted. We subtracted the 3x, we divided by 2, so we end up with a negative 3x squared minus 1 for my slope-intercept. I did not have to change the sign because I did not divide by a negative. So I'm going to put a point at 0, negative 1, and I'm going to be going negative 3. Positive 2 from my slope, and I'm going to go in the opposite direction. And it is a solid line in this case because this time I am dealing with a equal to symbol, and it's smaller than our numbers that are smaller or less than symbols. We're going to go below that. So you'll notice that my double shaded area becomes this area right here. Okay, where points that are on this line are not included in the graph, but points that are on this line are. and anything over in this area. Alright, question number 4. Here's another example where we have gone ahead and converted these into slope-intercept form. Subtracted the 3x divided by 4. No need to change the sign on that. Okay, just a quick recap if you don't remember how to convert these. We're going to subtract the 6x. We end up with 4y is greater than negative 6x plus 12. We're going to divide by 4. Negative 6 divided by 4 simplifies to negative 3/2. And 12 divided by 4 simplifies to 3. I am glad that I did that because I got an error here. It ends up being a negative 3/2 x plus 3. So I'm going to have 0, 1, 2, 3, and a negative 1, 2, 3, 1, 2, negative 1, 2, 3, 1, 2, 1, 2, 3, 2, another point, and it is a, there's no equal to, so I'm going to use dashed lines on this one. And I am going to be working with numbers that are smaller than this, or sorry, greater than, so I'm going to be going above this line. So I'm going to shade up above this. Okay, then on the next one, let's just double check that I didn't make an error here, but we are going to subtract the 3x, and so we end up with negative 4y greater than negative 3x plus 8. I'm going to divide by the negative 4. Because I'm dividing by negative 4, I'm actually going to switch that sign. And the negative 3 divided by negative 4 becomes a positive 3/4 x. 8 divided by negative 4 becomes a negative 2. So that one was correct. I just must have had a typo there. So I'm going to have 0, negative 2 here. I'm going to go up 2, 3, 1, 2, 3, 4. Up 1, 2, 3, 1, 2, 3, 4. Down. Okay, and it's also a dotted line because there is no equal to symbol. Oops. And it's shaded below that, so I'm going to use another color to represent down below that. And so our doubly shaded area is here, continuing on forever. None of the points on either line are going to be included in the solution. Alright, so let's look at one more example. So this time Sarah's pet store never has more than a combined total of 16 cats and dogs. She also never has more than 9 cats. So we're asked to write a system of inequalities and graph to show the possible numbers of cats and dogs in her store. So first off, we have to define our variables. So I'm going to call C the number of cats. I'm going to make that my x-axis. And I'm going to call D my y-axis, the number of dogs. That's what I'm looking for. Okay, and I have two different things here. So first off, she never has more than 9 cats. So the number of cats has to be less than or equal to 9. Okay, so that's my first equation. The second equation here is that she never has more than a combined total of 16 cats and dogs. So C and D has to be less than or equal to 16. Now, if I want to get these ready to graph, I would convert this, which I've already done here. I would subtract the C, and I end up with D is less than or equal to negative C plus 16. So I can graph this. C is less than or equal to 9. I'm going to put a point at 9. At C is 9. 2, 3, 4, 5, 6, 7, 8, 9. And that's going to make a vertical line, and it is a solid line. Okay, and the number of cats have to be less than 9, so I'm going to be coloring in numbers that are smaller than 9. That's to the left. Okay, then from here we're going to graph this at 16. 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. I'm going to go up one above that, and at a slope of -1. It is also an equal to, so I'm going to use a solid line, and it is numbers less than that as well, so I'm going to be shading in everything below this. So where our solutions will lie is that she can have any combination that falls in between these barriers, including numbers that are on the solid lines. Okay, and so that's what this is going to look like when we put it into an application type question.